Okay, this is project test number 2. This is the first video, and this will cover problems 1 through 10. So, height in meters is measured for each person in the sample. After the data are collected, all height measurements are converted from meters to centimeters by multiplying each measurement by 100. So we're going to be multiplying. This is going to be an important notation. Which of the following statistics will remain the same for both units of measurement? Well, when we measure and when we multiply, if we multiply by a constant, then does your height change? Yes. So measures of center change by the multiple, as do measures of spread. So measures of center and spread both change when you multiply. And they want them to remain the same, so they're not going to remain the same. If something was 10 centimeters and you multiply by 100, it's now going to be 1,000 centimeters. So basically, measures of center are going to change by the multiples. So that means the mean and the median will both change, and we're looking for something to stay the same. The standard deviation of the height measurements, that'll change because measures of spread change by the multiple. The maximum of the height measurements will change because if the tallest thing was 10, we multiply by 100, it's now 1,000. So the maximum of the height changes, but the z-score does not change. Because remember, z-score equals z equals x minus mu over sigma. And essentially, we are now multiplying the numerator by 100, and we're multiplying the denominator by 100. So they cancel out. And as a result, the z-score remains constant, even though we're multiplying by a constant multiplier. So the z-score doesn't change, but the measures of center and measures of spread will change when you're multiplying by a constant. Now, if you're adding, the measures of center change, but the measures of spread do not. Okay? All right. Moving on to number 2. A school principal wanted to investigate student opinion about the food served in the school cafeteria. The principal selected a random sample of 50 first-year students, 50 second-year students, and 50 third-year students, and 50 fourth-year students. So basically, we have freshmen, sophomores, juniors, and seniors to complete a questionnaire. Which of the following best describes the sampling plan? So we basically chose groups. Anytime you choose groups, you know it's either going to be a stratified or a cluster. As soon as you choose groups, it's going to be stratified or clustered. But if I break them into groups and then select within the group, that's stratified. Breaking them into a group or category where everyone is the same. So basically, we have all freshmen grouped together, all sophomores grouped together, all juniors and all seniors. So I'm going to make it like this. We have FR for freshmen, SO for sophomores, juniors, and seniors. All right, and I'll have FR, 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 SO, 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 because you could make this into a cluster, but that's not what they did. They made this into a stratified. In the stratified sample, we'd have this is a group, and then I'd randomly select from that group. This is a group, I go to that group and randomly select from that group. This is a group, I randomly select from that group, and this is a group, and I randomly select from that group. This way, I'm ensured of representing freshmen, sophomores, juniors, and seniors. But I could have done this by a cluster by doing it slightly differently. This would be cluster 1. This would be cluster 2, cluster 3, and cluster 4. If I set this up as a cluster, I'd randomly select a cluster and then survey everybody in the cluster. But since this is strata, we have strata 1, strata 2, strata 3, and strata 4. I randomly select one of the strata. I go to each strata. So I go to the first strata and make a random selection from the strata. Maybe I select this person randomly. I go to this strata and I make a random selection. Maybe it's this one. I go to this one, I made a selection here, and I go to the seniors and I make a random selection. All right. So the question is when did you break them into groups and how did you do it? If you survey everyone in the group, it's a cluster. If you go to every single one of the groups and take some from all of the groups, it's a strata. Okay. A candy company, number 3, produces individually wrapped candies. The quality control manager for the company believes that the weight of the candies is approximately normal with the mean is 720. So essentially, I have a mean of 720. If the manager's belief is correct, which of the following intervals of weight will contain the largest proportion of candies in the distribution? Well, the fact of the matter is I could have gone to all of these and just done a norm CDF for all of them. And I'll do that for the first one real quickly so you can see it. But they didn't give a standard deviation. And since they didn't, I'm kind of stuck. All right, because you're looking, because otherwise I'd go second bars, norm, CDF, lower bound, 740, upper bound, 780, mean is 720, and then I'd put in some standard deviation. They didn't give me a standard deviation. Not that it's really critical here, because if I look at these, they did something kind of special. This distance is 40. This distance range is 40. This has a range of 40. This has a range of 40. And this also has a range of 40. So what they want you to get out of this problem is that if you're centered about the mean, you're going to have the largest proportion. So since it's 40, I'm going to want 20 below, which is 700, and 20 above, which is 740. So basically between 700 and 740 is going to be my largest quantity, okay? So my largest quantity of data will be in that range, which is going to be B. This will be the largest percentage. And it's like that because it's centered about the mean. And you can see that it's taller. So consequently, even though the horizontal distances would be the same, it's taller. So we have more area and more data there. All right, number 4. A company currently uses brand A light bulbs, which have a mean life of 1,000 hours. A salesperson marketing brand B, a new brand of light bulb, contacts the company. The company will switch to the new brand of light bulb only if there's convincing evidence that the mean brand of B is greater than 1,000 hours. Which of the following should be the company test? Well, so if I'm just writing this out, I go, well, the assumption is that the mean brand of B is 1,000. The alternative, I'll make a change if the mean brand B is not 100, but is 1,000, is greater than 1,000. So which one actually looks closest to that? When I very first looked at the first one, it says the mean life brand of B is 1,000, so equals. That looks good. The mean brand life of brand B is more than 1,000, so greater than 1,000. So putting in the words, and it looks like 4A is going to be my best choice fairly easily on that problem. Number 5. This one's a little trickier, not particularly difficult, but a little bit trickier. So the amount of time required for each of 100 mice to navigate through a maze was recorded. The histogram below shows the distribution of times in seconds for the 100 mice. Which of the following is closest to the standard deviation of the times? Well, when I look at this, it's like, well, I don't have a vertical scale, so there's not a whole lot I can do to actually really do a good job calculating it. So I'm going to kind of fit a curve to it. And I say kind of fit it. It's not perfect. So if I say this, you know what, this looks about the center. How far above do I go? Well, it looks like I went 30 above. And this kind of looks like a normal distribution. So that means I should have 3 standard deviations. So 30 divided by 3 is approximately 10. If I do this same thing here, I go 60 to 90, And it's like, you know what? This distance is also 30, and 30 divided by 3 is also 10. Well, some of you are going, hey, you know what? This really only went to 65. So my distance is 25. It's like, okay, 25 divided by 3 is 8 1/3. Well, what's my closest answer? Regardless how you, on this particular one, it's not close. It's obviously not 2.5, and it's certainly not 20. So my best answer is going to be 10, which happens to be letter B. And no, it's not perfect. You're going to have to do some estimation on that. All right, number 6. A graph not shown of the selling prices of homes in a certain city for the month of April reveals that the distribution is skewed to the left. So as a reminder, skewed to the left is going to look something like this. Not a very good look, but has been stretched to the left. They say skewed to the left, so stretched to the left. Which of the following statements is the most reasonable conclusion about the selling price of the graph? The mean is equal to the median. No, if this were the median, because it's stretched to the left, we would say the mean is to the left. So obviously the mean is less than the median. So no, the mean is less than the median, not greater. So that's not true. The median is average of the first quartile and the third quartile. Well, let's get back to that in just a second. Let's go ahead and say, you know what? Since they're saying third quartile and first quartile, let's kind of go ahead and sketch a box plot to this. Well, if I were sketching a box plot, that's going to be my max, and my minimum is going to be here. And I just said that this was my median. Well, that means somewhere between here and here, I've got to put a third quartile. I don't know where it goes. I just stuck it there. So this is my max. This is my Q3. That's my median. We've already labeled it. Q1 is probably going to be a little bit down this way. It's going to be because it's stretched. So this could be Q1 somewhere down here. And this is my min. Well, clearly the median is not in the center. So obviously it's not the average. And matter of fact, the median is the average of the first and third quartile only if it's symmetric. That's only true if it's symmetric. Otherwise, that's not likely to be true. They said it was skewed, so the median is not the average here. So that's not the case. There are fewer selling prices between the first quartile and the median than they are between the median and the third quartile. Well, fewer between the first quartile and the median. Well, this is 25%. So 25% of my selling prices are here, and 25% of my selling prices are here. So that's actually the exact same number of values. So here we have the same number of values because it's 25%, 25%. It's spread out, but it's the same percentage. There are more selling prices that are less than the mean than selling prices that are greater than the mean. Well, when I look at this, half of my selling prices are above the median. So that means more than half are above the mean and less than half are below the mean. So that's false because less than half, it says more selling prices that are less than the mean. Is go, no, they're less selling prices because once again, half my prices are above, are the median and above. So this means the mean and above is more than half. So this is going to be less than half. Then they talk about the value of the maximum minus the third quartile is less than the minimum value minus the third quartile. Well, I can look at the distance and go, you know what, this should be different, but maybe it'll help if I just put a number line. So let's put a number line, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Well, in this case, the distance between Q3, the max and Q3 are 9 minus 8 just happen to equal 1. Whereas when I look at from here to here, 4 minus 0 means Q1 minus min is 4. So the value of the maximum minus the third quartile, which is 1, is less than this value. And I just made up those numbers, but basically all they're saying is this distance here is less than this distance there. So 6 is E. Number 7, a survey was conducted in which both men and women were asked a question about a current issue. Possible response were in favor of, not in favor of, or no opinion. A chi-squared test, oh, that's going to be important. We'll talk about a chi-squared, is to be used to determine whether the response to this question is independent. Oh, that's the other key word I was looking for. So this is the chi-squared test of independence. Is independent of gender. The number of degrees of freedom for the chi-square test is what? So they want the degrees of freedom. Well, first off, I need to remember that for a chi-square test of independence, degrees of freedom is row minus 1 times columns minus 1. Like, well, but we don't have any rows and columns. Well, we're going to need to make them. All right, so we have answer choices are IF for in favor, NF for not in favor, or no opinion. So we know we have 1, 2, 3 possible this way. And then they're going to see if it's independent of gender. And here they said men and women. So we're classifying as only 2 genders here. So we have 1, 2, 3 rows. So 3 minus 1. And 1, 2 columns. So 2 minus 1. So 2 times 1 equals 2. So our degrees of freedom in this case is just plain old 2, which is letter D. And if you'd swapped your rows and columns, it wouldn't have mattered. It still would have given you exactly the same answer. There's not a correct way to assign those. Okay, number 8. If a probability distribution is symmetric, which of the following must be true? Well, please remember, probability symmetric can be several different shapes. It might look just like a parabola, something like this. It could be mound shape. Could be uniform, because I could cut that in half. It might even be bimodal or multimodal, because again, I can cut this in half. So, does the distribution have to be normal? Well, apparently not, because all of these shapes are symmetric, so they're not. The distribution has to be uniform. No, it could be one of these other shapes. The distribution is bimodal. Well, no, it could be one of the other shapes. The mean of the distribution is equal to the median. And the fact of the matter is that will always be true. Now be real careful. Some people will say it also equals the mode. No, that's only if it's mound shaped. Because here's where the mode is on this one. But obviously the mode is not here. The mode is on the edges on this one. So the mean and the median will be equal if it is a symmetric distribution. Number 9, let X represent the number on the face that lands up when a fair 6-sided dice cube is tossed. The expected value is 3.5. Okay, so the expected value is 3.5, and the standard deviation is approximately 1.708. 2 fair-sided die will be tossed, and the number appearing on the face will be added. Which of the following is closest to the standard deviation? All right, so before I get to the standard deviations, they didn't ask me this, but remember, I can add the expected values. So the expected values, if I add it, we're just to go 3.5 plus 3.5 equals 7. So if I roll 2 dice, what I expect to get, this would be my expected value, but they didn't ask that. They asked for standard deviation. They're like, okay, we're going to add them. So I want to go standard deviation of the first dice, and I have a standard deviation of the second dice. Now they're asking me to add, so I want to do my initial impulse is just to do that. But we cannot add standard deviations directly. The very first thing we must do is combine them, convert them to a variance by squaring them. Then we can add them, and then we can take the square root of them. So in this particular case, 1.708 squared plus 1.708 squared equals, now don't forget to come back and take the square root of that. So I'm just going to raise it to the half power. And I end up getting 2.415 is my best answer. Now, if I'd had a whole long list of these, it might have been easier for me to go 1.708 squared, just like that, and put a 2 in front. Because if I had to do it 10 times, that way I wouldn't have to write it 10 times. And that would give me the same answer. Because basically I'm adding these two. So that's like putting a 2 out in front. But you don't have to go about doing it that way. You can always do it this way. So that's number 9. Number 10, based on previous research, the standard deviation of the distribution of the age at which children begin to walk is estimated to be 1.5 months. So this is the standard deviation. So they're telling us, hey, we have a standard deviation of 1.5. A random sample of children will be selected and the age at which each child begins to walk will be recorded. A 99% confidence interval for the average age of children begin to walk will be constructed using the data obtained from the sample. Of the following, which is the smallest sample size that will result in a margin of error of 0.1 month or less? So here we go. X bar plus or minus Z star standard deviation divided by the square root of n. Well, this part right here equals the margin of error. All right, so they're saying that they want this to be no more than 0.1 months. We can calculate Z star by doing a second VARS inverse norm. So second VARS inverse norm, parenthesis 1 minus 0.99, close parenthesis, divided by 2, mean is 0, standard deviation of 1. And we end up getting 2.576. Times my standard deviation, which is 1.5, divided by the square root of n. I'm going to go ahead and divide both sides. Well, I'm going to go ahead and multiply these 2.576 times the 1.5. And I end up getting 3.864 over the square root of n equals 0.1. Doing some manipulation, I can multiply both sides by the square root of n. This goes away. I'm going to go ahead and do this in the same step and divide both sides by 0.1. So now I have 3.864 over 0.1 equals the square root of n. Raised to the second power. So 3.864 divided by 0.1. And I need to go ahead and square it. And I end up getting 1493. Now, immediately, some of you all are freaked out. 14.05. So I need to round up. So this is 1494. So I need the next answer that is larger than this. So I need an answer larger than 1494. So 400, no. 900, no. 1300, no. So the first one that's larger is 1600. So my answer to this question is 1600, even though we counted 1494. And please notice, I rounded this up. Even though I had a very, very small decimal, 0.05, I still had to round up to 1494. And then it's like, okay, 1494 is not an answer. I need the next one that's larger. All right, so 1600 or D. All right, thank you.